Let's take a look at question 13.12. Assign a name for each of the following compounds. Be sure to assign the configuration of each chiral center and indicate the configurations at the beginning of the name. Okay, so we're going to have to employ Kahn-Ingold Prelog rules. So let's start by naming 13.12a as an oxirane. So hopefully you can see it's going to be a 1, so it's going to be a 2-phenyl and a 2-methyl, but methyl should come first because M comes before P in the alphabet, so it's going to be something 2-methyl 2-phenyl oxirane. A common name for oxirane is ethylene oxide. If I wanted to assign the stereochemistry, I have the methyl group, which is going to be lowest priority. I have the oxygen, which is going to be top priority. This carbon here is attached to 1, 2, 3 carbons. So this one, if I make my decision tree like we did in 3101, that's attached to 3 carbons like this. And this methylene here, that carbon is attached to an oxygen and 2 hydrogens. So this is going to be my tiebreaker. So therefore, the stereochemistry is going clockwise, which is R. So I assign that R. So it's R2-methyl 2-phenyloxirane. If I want to name this as an epoxy compound, my stereochemistry doesn't change. You can see that the longest carbon chain starts here, 1, 2, 3, and the reason I chose to start numbering from the right instead of on the methyl group is because then I get a 1,2 epoxy propane as opposed to a 2,3 epoxy propane, and I want to give the lowest possible number. So in that case, I would name the compound R2 2-phenyl 1,2 epoxy propane. So since propane has 3 carbons, it takes care of the methyl group as well. Okay, moving on to the second one, B here. This one is the one that I think there is a mistake in our textbook, because if you name this compound as an oxirane, okay, obviously the oxygen is going to be number 1, but we have 2 alkyl groups. We have an ethyl group and a propyl group. The ethyl group should actually take priority based on E coming before P in the alphabet. So there we go. So this is going to be 1, 2, 3 like that. Okay, when we start numbering our oxirane. So with that in mind, I'll just get rid of the number 1 there. So I need to assign the stereochemistry at carbon 2 and the stereochemistry at carbon 3, because I know that I'm going to have a 2-ethyl and a 3-propyl oxirane, like that. Okay, so if I want to assign the stereochemistry for carbon 2, let me get the red pen out here. So the oxygen is obviously number 1. This carbon here is going to be carbon number 2 because it's attached directly to an oxygen, whereas this CH2, its decision tree or whatever you want to call it, would be CHH. So you can see the stereochemistry is going counterclockwise the way I have it, but it would be reversed and being clockwise because the lowest priority group, the hydrogen, is coming out in front. So this must be a 2R compound, and then we have to assign the stereochemistry at carbon 3. We'll do this one a little bit faster. I'll get the blue pen. So this is going to be our first priority group, the oxygen. This will be our second priority group because this carbon is attached to the oxygen, and then this would be our third priority group. So this group is also R. So we have 2R, 3R, 2-ethyl, 3 propyl oxirane. All right, so if we want to name this as an epoxy compound, so I've written quite a few things here, so let me do some erasing here. So if I want to label this as an epoxy compound, or name this as an epoxy compound, you can see the longest carbon chain is 1, 2, 3, 4, 5, 6, 7. So now my stereo centers are at carbons 3 and 4, so it's going to be a 3 something, 4 something, okay? And then it's going to be in an epoxy heptane, and it would be 3,4 epoxy heptane. So I'll put that in here. So 3,4 epoxy heptane. But of course, the stereochemical assignments don't change in this molecule, so we're going to put 3R and 4, 3R and 4R, like that. So we have 3R, 4R, 3,4 epoxy heptane. The next one, let's try naming this one as an epoxy compound first. I think it's actually a little bit easier to name this as an epoxy compound because if you have 1, 2, 3, 4, 5 like this, then I give my epoxy 2, 3 epoxy. So I'm going to have a 2, 3 epoxy and I have a 4 methyl. So it's going to be something where I have 4 methyl and then I have 2, 3 epoxy pentane because there's 5 carbons like that. So 5 carbons in a row. All right, so now I just need to assign the stereochemistry for those 2 stereocenters. So I have 2 something and 3 something and then my hyphen here. So let's determine the stereocenter for carbon number 2. So if I look at carbon number 2, you can see the oxygen is going to be first priority. Carbon number 3, that group will have second priority because this carbon is attached directly to an oxygen, which means it's going clockwise. So it's going to be 2R. Again, the lowest priority group, the hydrogen, is not drawn, but that's in back. For carbon number 3, I'm going to do the same thing. I'm going from the oxygen, of course, again to carbon 2. So therefore, I am going counterclockwise. And my lowest priority group is in the back. So it's going to be 2R3S. So I have 2R3S, 4-methyl, 2,3 epoxy pentane. And if I want to name this as an oxirane, well, then it gets a little bit more interesting because you can hopefully see that the 2 groups on the ring are an isopropyl group and a methyl group. An isopropyl, we don't ignore the prefix iso, so iso should come first. So in that case, we should number the ring 1, 2, 3. So it should be a 2 isopropyl, 3 methyl oxirane. So we can write that in 2 isopropyl, 3 methyl oxirane. And then you can see that carbon number 2 is the S stereocenter and carbon 3 is the R stereocenter. So they actually switch, they just switch numbers. Of course, you're not inverting stereochemistry. That's not going to happen. So we have 2S and 3R in this case. All right, so there you go. So that's naming 3 different chiral epoxides using both oxirane nomenclature systems and using the epoxy nomenclature system. I hope you found this video about epoxide nomenclature useful.